Hello everyone, you're welcome to this tutorial, and once again my name is Peter from Learnwithuncletee. Now in this tutorial we're going to discuss integration by trigonometric substitution. So let's get into it. Integration by trigonometry substitution. Now, for this tutorial, we are going to limit it to two forms. And the first form is if we have a form, an integral form that resembles the square root of a square minus x square, or 1 divided by the square root of a square minus x square. So this is the first one. Why the second form is if we have an integral form that resembles 1 divided by a square plus x square. So basically, one of the first things that you need to know is that when you're dealing with an integral form that takes this form, you use the trigonometrical substitution of x is equal to a sine theta. Again, once you see a square minus x square, you use x equals a sine theta. Once you see a square plus x square, you're going to use x to be equal to a tan theta. So basically, let's go into some basic proving. Now, if we have x to be equal to a sine theta, take a look at this. If x is equal to a sine theta, if we are to differentiate x with respect to theta, you know that a here is multiplying sine theta, so we are going to use product rule. So say first times derivative of second. If you differentiate sine theta, you're going to get cos theta, plus second times derivative of first. If you differentiate a with respect to theta, you're going to get 0. So here it means that dx over d theta is equivalent to what? A cos theta. So if you make dx the Taylor formula, dx is going to give you a cos theta d theta. So this is an identity under trigonometry substitution that is still under integration. One of the other things that you can still derive from here is that if x is equals to a sine theta, it means that sine theta is actually equivalent to what? X over a. So since sine theta is equal to x over a, it means theta is equal to arc sine x divided by a. Okay, so now let's apply this in a question so that you understand what we're trying to do. So let's say that we are to evaluate integral square root of a square minus x square dx. So we know that a square minus x square. Let's try solving that first. The square root of a square minus x square will give us, if our x is a sine theta, so anywhere we see x here, substitute a sine theta, this will give us the square root of a square minus a square sine square theta. So if you factorize a square out, so the square root of a square will give you a. You'll be left with 1 minus sine square theta. 1 minus sine square theta is the same thing as cos square theta, and the square root of cos square theta is going to give you cos theta. So it means that the square root of a square minus x square will give you what? A cos theta. So instead of writing square root of a square minus x square, it means that this is equivalent to a cos theta multiplied by dx. Our dx is what? A cos theta d theta. So this is a cos theta d theta. So if you multiply this, will give you a square cos square theta d theta. So this is the same thing as if you factorize a square out, you'll be left with cos square theta d theta. So let's try integrating cos square theta. We have to simplify this to a very basic form first. We know that because we can't just integrate this, we have to bring in substitution, and before we can bring in substitution, we have to look for a way to eliminate this power of 2. So since we know that sine square theta plus cos square theta will give you 1. So it means sine square theta is equivalent to 1 minus what? Cos square theta. So we also know that cos square theta minus sine square theta is actually going to give you cos 2 theta. So what it means here is that cos square theta minus sine square theta is 1 minus cos square theta will give us what? Cos 2 theta. So this cos square theta minus 1 plus cos square theta to give you what? Cos 2 theta. So cos square theta plus cos square theta will give us 2 cos square theta minus 1 is equal to cos 2 theta. If you then make cos square theta a sort of formula, it means cos square theta is the same thing as cos 2 theta plus 1 divided by what? Divided by 2. So you discover that if we represent cos square theta as cos 2 theta plus 1 divided by 2, we'll be able to easily integrate cos 2 theta by using integration by just basic substitution. So you don't even need algebraic substitution to solve that, which will make your calculation very much easier. So what it means here now is that integral a square cos square theta d theta is now the same thing as a square multiplied by integral cos 2 theta plus 1 divided by 2 d theta. So this is a squared divided by 2 integral cos 2 theta plus 1 d theta. Okay, so when you integrate this, a squared divided by 2 multiplied by, using algebraic substitution to integrate this will be 1 over 2. So that's sine 2 theta plus theta plus arbitrary constant c. So where we got this theta from is when you integrate 1 with respect to theta, you're going to get theta. Okay, so basically, this is actually going to give us, since now we have a square over 2 integral a square over 2 times this, okay, we can decide, because I'm trying to eliminate this theta. Since we don't have any representation for theta, we can see that this is a square divided by 2 multiplied by the LCM of this and this is will be 2. So this will be sine 2 theta plus 2 theta plus an arbitrary constant c. So this is actually going to give you a squared divided by 2 multiplied by sine 2 theta is the same thing as 2 sine theta cos theta plus 2 theta. Everything now being divided by 2. Yes, okay. So plus arbitrary constant c. So this is a squared divided by 2 multiplied by 2 into this 2. This 2 will cancel this 2. So we'll be left with sine theta cos theta plus theta plus arbitrary constant c. So if we use a square over 2 to multiply, to open the bracket, that will be a square divided by 2 multiplied by sine theta cos theta. Okay, let me try dividing this so that you won't get confused. Okay, a square sine theta cos theta plus a square divided by 2 theta plus arbitrary constant c. So we can actually find representations for sine theta and cos theta. That x is equal to a sine theta. We have proved this x equals a sine theta. It means that from here, sine theta is equal to what? X over what? A. So x of sine theta basically means opposite over what? Hypotenuse. So from Pythagoras theorem, hypotenuse square is equivalent to opposite square plus what? Adjacent square. So our hypotenuse here is a. So a square will give us our opposite, that's x square plus adjacent square. So if you make your adjacent the subject of formula, this will give you the square root of a square minus what? Minus x square. So it means that we can find cos theta, and we know that cos theta is our adjacent over our hypotenuse. So our adjacent here is square root of a square minus x square divided by our hypotenuse, which is what? A. Okay, so it means we can leave this as a square divided by 2 multiplied by sine theta. Our sine theta is what? X over a. So this will be times x over a multiplied by cos theta times square root of a square minus x squared divided by a plus a squared divided by 2 times theta. Don't forget our theta is arc sine x over a. So that is arc sine x over a plus arbitrary constant c. We can cancel out here. Okay, a times a will give us a square. A square will cancel a square. So here we are left with x over 2. So this will give us x divided by 2 multiplied by the square root of a square minus x square plus, okay, plus a square divided by 2 arc sine x over a plus arbitrary constant c. And this will be the final answer to that question. So it means when you integrate the square root of a square minus x square with respect to x, you're going to get x over 2 roots a square minus x square plus a square over 2 arc sine x over a plus arbitrary constant c. Okay, so now let's consider another form now. Okay, so for the first, for the first example, we have considered that's root a square minus x square, and I said that if you still want to do for one over root a square minus x square, you're still going to use the substitution x equals a sine theta. So basically, I'm supposed to go straight into this, but let me still try explaining if it is 1 divided by square root of a square minus x square. So let's take an example also on that. Let's say we have integral 1 over square root of a square minus x square. So that's with respect to x. So we know that our a square minus x square is already the same thing as a cos theta from here. So dx is what? Our dx is a cos theta d theta. So you discover that a cos theta here will cancel a cos theta. You'll just be left with integral. That is integral 1 d theta. So when you integrate 1 with respect to theta, you get theta plus arbitrary constant c. And your theta is what? Arc sine x over a plus arbitrary constant c. So it means that if you integrate 1 divided by square root of a square minus x squared dx, you're going to get arc sine x over a plus arbitrary constant c. Okay, so now let's consider, we have considered the square root of a square minus x square. We have considered 1 divided by square root of a square minus x square. So now let's consider 1 over a square plus x square. So contrary to a square minus x square, once you see that it follows the form a square plus x square, you're going to use the trigonometric identity, or let me say the substitution x is equals to a tan theta. So let's solve that now. Okay, so if we have integral 1 divided by a square plus x square, so of course we are using the trigonometric identity x is equals to a tan theta. So same approach, if you find dx d theta, first times derivative of second, if we differentiate tan theta, you're going to get sec square theta plus second tan theta times derivative of first. If we differentiate a with respect to theta, you're going to get 0. So here we have dx d theta is equivalent to a sec square theta plus 0. So what it means is that dx will give you a sec square theta d what? D theta. So yeah, what it means is that integral 1 over a square plus x square. Okay, before we also go there, we are representing this. This is still dx. If we say a square plus x square, if our x is a tan theta, so we are going to have a square plus a tan theta raised to the power of what? 2. We have substituted x to be a tan theta. So this is a square plus a square tan square theta. If you factorize a square out, you'll be left with 1 plus tan square theta. And don't forget, 1 plus tan square theta is the same thing as sec square theta. So this just a square sec square theta. So a square plus x square, that's where we started from. A square plus x square is actually going to give us what's a square sec square theta. Okay, so now let's come back to what we're solving. This will now be integral 1 divided by a square plus x square is now what? A square sec square theta multiplied by dx. Our dx is what? A sec square theta d theta. So a square sec square theta will cancel a square sec square theta. We will left with integral 1 d theta. And integral 1 d theta, oh sorry, this a, this a square. So that's 1 over a. That will be 1 over a, yes. So a in a square, that's 1 over a. Sec square theta will cancel sec square theta, okay? So this will be 1 over a times, if you integrate 1 with respect to theta, you get theta plus arbitrary constant c. So we therefore have 1 over a times our theta, okay? Since tan theta from here will give us x over a, it means that theta will give us arctan x over a. So our theta here is arctan x over a plus arbitrary constant c. So that's 1 over a arctan x over a plus arbitrary constant c. Okay, so what's the essence of everything that we are doing now? So let's take an application question so that you understand what we are trying to do properly. So we are to evaluate integral 2 divided by x squared plus 5 dx. Okay, so don't forget, we are using the trigonometric identity that we are substituting our x to be equal to a tan theta. So, but firstly, you have to compare this. If you compare 2 divided by, okay, let me first reduce this so that I won't just compare it with 2. Integral 2 over 1, integral 2 divided by x squared plus 5 is the same thing as 2 integral 1 over x squared plus 5 with respect to x dx. So now let's compare 1 over x squared plus 5 with the general form, which is 1 over a squared plus x squared is equal to 1 over x squared plus 5. They have the same numerator, so it means that a squared plus x squared is equal to x squared plus what? Plus 5. From here, it means a squared is equal to 5 and a is equal to root 5. So don't forget, from the previous question, we have derived that a squared plus x squared is equivalent to a squared sec square theta. So what it means here is that you know that if we rearrange this is now saying 5 plus x squared. That is when our a is equal to root 5. It means this will give us a square, which is now 5 sec square theta. And we also know that dx is equal to a sec square d theta, a sec square theta d theta. So it means that this will give us dx is equal to root 5 sec square theta d theta. Okay, so this will give us 2 multiplied by integral 1 divided by x squared plus 5 is now what? 5 sec square theta. So that's from here. 5 sec square theta multiplied by dx is now root 5 sec square theta d theta. So this gives us 2 multiplied by, we can factorize root 5 over 5 out. So that will be 2 times root 5 divided by 5 sec square theta will cancel sec square theta integral 1 d theta. So what this means is that this will give us 2 root 5 divided by 5 multiplied by, if you integrate 1 with respect to theta, you get theta plus arbitrary constant c. So this will give us 2 root 5 divided by 5. Our theta, don't forget, theta is equal to arctan theta is equal to arctan x over what? X over a. So it means our theta here is going to give us arctan. Our x is what? Is still our x. Our a is what? Root 5. So this will give us 2 root 5 arctan x over root 5 plus arbitrary constant c. And that will be the final answer. So basically, in integration by trigonometrical substitution, a remark is that once you see a square minus x square, you use a sine theta. Once you see a square plus x square, you use a tan theta. So for this tutorial, this is where we're going to bring it to an end. Don't forget to subscribe. If you have not subscribed to our channel, you can hit the subscribe button. And if you have any questions, you can leave it in the comment section. Do well to share with your mates so that they will have more access to the tutorial. Once again, see you in the next tutorial. This is Peter from Learnwithuncletee.